Yes, good morning, dear students. So, today we shall conduct a class, a session on GATE exam preparation, and the subject for today's class is electrical circuits. And I am glad to let you all know that these all classes are sponsored by AICTE Prerana Center that we have at our institute, Vidya Pratishthan's Kamalnej Bajaj Institute of Engineering and Technology. And this is a scheme offered by AICTE specifically for the growth and progress of SC and ST students to help them prepare better for GATE and other examinations. Today, that is on 11th of September 2021, we shall deal with session 1 of electrical circuits during the period 11:15 to 1:15. The topics that will be covered today are equivalent resistance, KVL, KCL, dependent sources, and Thevenin theorem, and one more is maximum power transfer theorem. So what we shall go through is, we shall go through the basic concepts of these headings that I told you, and numericals that have appeared in the examination, GATE examination, in last 5 to 6 years based on these topics. So please be with me, and wherever you have any doubt, you can definitely ask me. Now, we shall go into few basics of these topics, and we shall start with the numericals based on these topics. Now, if you all be knowing that in GATE examination, usually numerical on calculating equivalent resistance of the network appear. So calculating equivalent resistance of the network depends on calculating series, parallel resistances, combination of series, parallel, and sometimes you may also have to employ your knowledge of star delta transformation. Then numericals usually appear on power resistance relationship. So what is power resistance relationship? P is equal to I square into R or V square upon R. These are the two relationships that we must be aware of to solve numericals based on power resistance relationship. Then we have circuits involving simply DC voltage sources, which you know look like a simple battery, or they can be represented as a circle having positive and negative polarities mentioned. Then we may have circuits involving current sources, which are represented by a circle. Inside the circle we represent the direction of current. And then we may have circuits wherein dependent sources are also there. Then what are the dependent sources? There are two types of dependent sources. There are dependent voltage sources and dependent current sources. They are also present in the circuit. So dependent voltage sources can be represented in this manner. Anyways, any dependent source is represented by a diamond shaped box, we can say. So this represents dependent source, and if inside the dependent source, if you see polarities plus and minus, then it is voltage dependent source. Then it is dependent voltage source. Sorry, it is dependent voltage source. And if inside the diamond, if you see an arrow representing the direction of current, arrow is actually representing the direction of current. So what I ultimately mean is, if inside a diamond, if you see presence of an arrow, it is a current source, dependent current source. Okay, and arrow represents the direction of current of that current source. Then we must be aware of how to use Kirchhoff current law effectively to solve some circuits. And using Kirchhoff current law is as good as employing the method called as nodal analysis. What does Kirchhoff current law state is? We know that at any junction or at any node, summation of currents is equal to 0. Algebraic summation of currents is equal to 0. Where the word algebraic summation is very important. So at any node, we know that there will be outgoing currents and there will be incoming currents. So addition of all such outgoing currents and incoming currents will be equal to 0. This is what is stated by Kirchhoff current law. And because the word algebraic sum is important, we have to distinguish between the incoming currents and outgoing currents. So how does the distinction take place? We call outgoing currents as negative currents and we represent incoming currents as positive currents. The reverse is also okay. If we represent outgoing currents as positive currents, then we have to represent incoming currents as positive currents. And reverse is also true. Incoming currents are taken negative, then outgoing currents has to be taken positive. Then we know about the Kirchhoff voltage law and its importance. We know that in any loop, in any electrical loop or mesh, summation of voltages is equal to 0. Summation of voltages is equal to 0. By the word voltage, we mean here both EMF and potential drops or potential drops. So summation of EMFs and summation of potential drops is equal to 0. Algebraic summation. So the word algebraic summation is again important over here. The word algebraic summation tells us that rise in potential should be considered positive and fall in potential should be considered negative. The reverse is also true. If you consider rise in potential negative, then you have to consider fall in potential positive. The only thing is, whatever you assume, please stick to that assumption at least till you complete solution of that numerical. You cannot change your assumptions during the numericals. Okay, so you have to stick to that assumption. Then we will go through Thevenin's theorem and maximum power transfer theorem and numericals based on them. So one by one we shall go through the numericals. Firstly, this is a numerical that has appeared in the examination of GATE somewhere during 2015 to 2020. I have collected the numericals that have appeared from 2015 till 2021. Sorry, 2020. So this was a numerical appeared in the GATE examination, and here we are supposed to find out the resistance between the terminals A and B. And many of you may find it very easy and some of you may find it difficult. So let me firstly tell you what is actually finding resistance between A and B means. So resistance between any 2 points A and B is actually the opposition that will be offered for the flow of current when current is going to flow from A to B. So here in this case, if we keep this concept in our mind, let us assume current will enter somewhere from A and will come out of B. Now look at the circuit. You can clearly see that if current enters from A point, it has to go through all the resistances between A and B, and then and only then it will be possible for current to come out of the B. So here are number of resistances connected between A and B in different series and parallel combination. Now our job is to find out the equivalent resistance, a single value of resistance that will appear between A and B. So what we ultimately mean is we have to reduce this whole circuit into this one. We have to reduce this whole circuit into a simple one resistance network. And if you achieve that, you have found out the resistance between A and B. This is the simplest thing that we firstly should understand. Okay. Now to do that, we must firstly understand which resistances are connected in series and which resistances are connected in parallel. Unless we understand that, we will not be able to find this out. So let us start looking at this circuit. So look at this. Current will enter from A, will enter into 1 ohm, will reach to this point. And when it reaches to this point, it has got three paths where it can flow. So whenever current divides, it is as good as there are some parallel branches. First assumption is there are some parallel branches. Whenever current divides, there are some parallel branches. But we cannot conclude which branches are in parallel with this much of knowledge only, that current is dividing. So for confirmation, what you should confirm is, what is the definition of parallel branches? Parallel branches are those branches whose both terminals are connected together. So let us look at this, whose both terminals are connected together. Let us look at this point. So here 3 ohm, 6 ohm and 2 ohm. These are the three branches of which one terminal is connected together. So it is possible that these three are in parallel, but we should confirm it. So now look at this. 3 ohm has got the other end at this point. 3 ohm has got the other end at this point. And the other branch, 6 ohm, has got the other end at this point. Now if you look at these 2 points carefully, these are equipotential points. So equipotential points are those points between which there is presence of no other element, neither a battery nor any resistor, inductor or capacitor elements. So what does this mean is, it is as good as, let us call this point some C, then this point is also C. In that case, we can conclude that 3 ohm and 6 ohm, these are the two resistances which have their starting terminals connected together as well as finishing terminals connected together. It means 3 and 6 are in parallel. This is confirmed. Okay. Next is 2 ohm. We have to see whether 2 ohm is also parallel to 3 and 6. No, because 2 ohm has its finishing terminal over here, and this is not exactly equal to point C because of the presence of this 6 ohm. Because of the presence of this 6 ohm, we cannot call this C point and this, let us say, D point, they are not equipotential. So 2 ohm is not in parallel to 3 and 6, but 3 and 6 are in parallel with each other. Okay, moving ahead, let's come to this point. At this point, let us assume some current comes over here, and at this point current will divide. Now current will divide in 3 parts. One will go into this 3 ohm, the other will go into this 6 ohm, the third will go into this 1 plus 1 ohm. So let us look at which branches are in parallel. Firstly, before that, this can simply be understood that this 1 and 1 ohm are in series, because whatever current will flow through this 1 ohm will also flow through this 1 ohm, right? So 1 and 1 are in series, so 1 plus 1, 2 ohm. This can be done very easily later on. Now whether 6 ohm and this 2 ohm and this 2 ohm are in parallel. So look at this, 6 ohm has got starting terminal over here and finishing terminal at C. This 2 ohm also has got starting terminal at D and finishing terminal at C. Yes, so 6 ohm and 2 ohm are in parallel. 6 ohm and 2 ohm are in parallel. So 6 parallel 2 is what we can reduce this network later on. Now what was left was at point D, we concluded that these two branches are in series. Now whether this 3 ohm is in parallel to 6, whether this 3 ohm is in parallel to 6, yes, because starting terminal of 3 and 6 is D and finishing terminals are also same, that is C. So this is how you firstly have to conclude which elements will come in series to each other and which elements will come into parallel to each other. And how do we do that? Simply assume that current is as good as water flowing through pipeline and network is a pipeline structure, water pipeline structure. So if you can assume how will water be divided in pipeline, you can definitely predict how will current be divided in the circuit. So taking this into account, what we shall try to do is we shall try to follow the steps. So here in this case, I am trying to redraw the reduced circuit in one by one step. So let us firstly draw the outermost circuit, outermost boundary of the circuit, and then we shall plot the branches. So look at this carefully. This was 1 ohm, this was 3 ohm, and this was 2 ohm. And here was a presence of some 6 ohm branch already, and these two were 1 ohm and 1 ohm. Now we will redraw these branches. Now as I said, this 3 ohm, look at this carefully, this 3 ohm, instead of showing it connected between D and C like this, so let us name D and C over here as well. So see, what you need to do is you have to draw a 3 ohm resistance between D and C. So what they have done is they have drawn it diagonally in this rectangle. Instead of drawing it diagonally, what I prefer is I would draw it in this manner, because we know that these two are the same points. C point, if is drawn shown over here, is as good as it is shown over here. So instead of drawing it in diagonal manner, what I am doing is I am drawing it in this simple manner. Similarly, there is a branch of 6 ohm which was drawn diagonally. Instead of drawing it diagonally, I can show it in this manner. I can show it in this manner. So now it is very easy for you to understand this circuit. Now I hope everybody can clearly see that 1 ohm and 1 ohm are in series. 1 ohm and 1 ohm are in series. So instead of these two, please pay attention, I will be redrawing the circuit with reduction now in the same circuit. So you have to be attentive now. So 1 ohm and 1 ohm when added together becomes 2 ohm branch over here. Now instead of this 6 parallel 3, what I would do is I would replace it by its equivalence. So 6 parallel 3, what are the calculations? 6 into 3 divided by 6 plus 3 is equal to 2, is equal to 2 ohm. So instead of these two branches, between D and C, I can simply have one branch having equivalent resistance of 6 parallel 3, that is 2 ohm. Now Similarly, instead of this 6 parallel 3, I would have a replacement. 6 parallel 3 already calculated. So 6 parallel 3, we know it comes out to be 2 ohm. So we will get a branch of equivalence over here as well. Now, look at this. Then we shall again think of the division of current. To conclude, if you are getting confused, we can still think of. Let us assume current will flow here. So at this point, current will be divided, and at this point, current will be divided. So look at the point D again. So this 2 ohm and 2 ohm are in parallel with each other. This is confirmed because C is again their same finishing terminal. So 2 parallel 2. Whenever it is R parallel R, it is always R by 2. Please remember this. Whenever it is R parallel R, it is equivalent will be always R by 2. So 2 parallel 2 will be 1. 2 by 2, 1. So 1 ohm will be its equivalent. So instead of having these two branches now in between D and C, what I can have is, sorry, some lines unnecessarily got cleared off. Now between D and C, as I said, instead of 2 parallel 2, we should write 1 ohm. Now it can be seen that 2 and 1 are in series, so they will become 3 ohm. They will become 3 ohm. So 2 plus 1 is 3 ohm. 2 plus 1 is 3 ohm over here. And now 2 parallel 3 is what we have got. So 2 parallel 3 is equal to 2 into 3 divided by 2 plus 3. So this is 6 by 5. 6 by 5 is 1.2 ohm. So, and one more thing, sorry, this 0.8 ohm was over here since beginning of the numerical, which was not shown, but it can be shown right now because it is not at all affected during any calculation of ours. So ultimately what remains in the circuit is, so now these three resistances between A and B are in parallel. So resistance RAB is equal to simply 1 plus 1.2 plus 0.8, and hence the answer is 3 ohm. And hence the answer is 3 ohm. So I hope it was I could make it easy for you to understand how to solve such numericals. You have to reorient few branches so that you find it easy to identify whether they are in series or in parallel, and then the numerical is very easy. If you do that, you will get to know that numerical is very easy. Okay, so I hope it is understood. We shall go into next numerical. Yes, again a numerical based on the equivalent resistances. Numerical based on the equivalent resistances. Now I request you to read the numerical carefully. I would read it along with you. RA and RB are the input resistances of circuits as shown below. Here are two circuits wherein RA is shown over here and RB is shown over here. The circuits extend infinitely in the direction shown. Look at this. These are the directions shown. These are the directions shown, and it is said that they extend infinitely in the similar manner. They extend infinitely in the similar manner. So what they mean is this formation of loops by adding number of branches is infinite. There is no end to this. Which one of the following statements in such a case is true? Which one of the following statements? So statements are options over here. So statements are whether RA is equal to RB, whether RA is equal to RB is equal to 0, whether RA is less than RB, or whether RB is equal to RA upon 1 plus RA. So we have to choose the most appropriate answer over here. Okay, so most appropriate answer is to be chosen. Now look at this carefully. the word infinitely extending, it's so difficult to absorb that you will never be able to find the actual value of RA and RB, actual precise value or actual accurate value cannot be found in such a case. But then how to solve such numericals? The only thing is you have to look at the given circuits carefully. If you look at RA and RB carefully, look at RB. RB is 1 ohm in parallel with 1 ohm in parallel with this circuit. Okay, 1 ohm in parallel with this circuit. And now this encircled circuit that I just shown by red color encircling, do you see that this is simply RA? Look at this. It is 2 ohm. It is 2 ohm. Then you have got a vertical branch of 1 ohm. Yes, 1 ohm. The same pattern is repeating. 2 ohm, 2 ohm. 1 ohm vertical branch, 2 ohm, 2 ohm, 1 ohm vertical branch, 1 ohm vertical branch. And this is going to infinitely. So this is going to extend infinitely. So this is infinitely extending. This is also infinitely extending. So pattern is going to remain same. So now if you look at this carefully, it clearly suggests us that RB is actually like this. So this is 1 ohm that I am plotting over here, and ahead of the branch of 1 ohm, whatever is present is actually RA. So ultimately it means that resistance RB is like 1 parallel RA, is like 1 in parallel with the resistance RA. So we know this can be calculated as 1 into RA upon 1 plus RA. So what we get is RA upon 1 plus RA. So if this is the option, then we are done. Yes. Look at this. There is an option RB is equal to RA upon 1 plus RA. So this is kind of a simplest numerical, but it is playing with your sight or your eyes. It is simply playing with your eyes. So if you plot it, if you look at it carefully, there is nothing difficult to be done in such numericals. So you have to be very attentive while solving such numericals. We shall go ahead. Now, here is again another numerical based on, we can say, not exactly equivalent resistances, but this is, let us solve this. Okay, if I tell you the heading of this numerical, topic of this numerical, you will presume something and will not think of solving it. Now, in the portion of circuit shown, so this is not a complete circuit, this is some portion. Okay, yes, we understand that there is very few things shown in the given circuit. So it is some part of the circuit. If the heat generated in 5 ohm resistance, where is 5 ohm resistance? Over here, yes, is 10 calories per second. So heat generated is 10 calories per second is given. So let us call it, okay, we will note it over here. 5 ohm resistance has got 10 calories per second of heat generation. So this is numerical based on, we can say, heat and resistance relationship. And ultimately it means power and resistance relationship, because we know that when I amount of current flows through some resistance R, then the amount of heat generated is I square into R into T, where T is the time for which this current was flowing. So this is, and I square R is actually P. So as I said, these are the numericals based on power resistance numerical. There are numericals based on power resistance relationship. So let us discuss the what is asked. Then heat generated by the 4 ohm resistance, the calories per second. So what is given is simply amount of heat in 5 ohm resistance is given, that is 10 calories per second, and we are supposed to find out the heat in 4 ohm resistance. That's it. Okay, so such very less things we can say are given. The given information seems to be very less. Now, how should we solve such numericals? So let us go with what is given, and maybe we would think of some answer or some way of getting through it. So heat, as you know, is energy. Heat, as you know, is energy, and energy by time. Energy by time is power. Is power. So what we can do is the relation that we know is already we know is power is equal to energy by time. Energy by time, and energy that is mentioned over here is 10 calorie, and time that is mentioned is 1 second. So we can say power is given. Actually, calories per second when was said, the first thing that should come to our mind is what this unit stands for. This unit stands for calories is energy per second. So unit stands for power. Energy per time is power. So actually power is given. So power in case of 5 ohm. So I am writing 5 ohm as suffix to P. So power in case of power absorbed by 5 ohm, we can say, is given as 10 calorie per second. But we have got the unit of power as watt, and watt is not equal to calorie per second. Watt is equal to joule per second. Watt is equal to joule per second. So what can be done is, the simplest thing that can be done is 10 into calorie converted to joule. We know that 4.18. 4.18 is the multiplying factor when you convert calorie to joule. So this becomes 10 into 4. I am not multiplying the things. Maybe they will cancel out later. That is why I am keeping it as simple as that. So it can be 41.8 joule per second, or simply watt, or simply watt. So what we know is power absorbed in the resistance of 5 ohm is 10 into 4.18 watt. Now, now, looking at this information, what other thing can be found out? So we know only this much, and we need to find out the power in 4 ohm. See, calories per second in case of 4 ohm is asked. So ultimately it means we need to find out power absorbed by 4 ohm. What can be done is, one way of doing it is by using the formula V square by R, where V will be voltage appearing across 4 ohm. The other way is by finding the current that is flowing through 4 ohm and multiplying it with 4 ohm. So I square R. There are two such formulae which can be used. So let us firstly find out, let us firstly focus on finding either voltage across 4 ohm or current through 4 ohm. So let us try to find out whether we will be able to find out the voltage across 4 ohm. Okay. Now, voltage across 4 ohm can be found out by using voltage division rule. Look at this carefully. By using voltage division rule. But for that, we must know what is the voltage appearing across 4 and 6. What is the voltage that is combiningly appearing across the branch of 4 ohm and 6 ohm. If you look at the circuit carefully, the branch of 4 ohm and 6 ohm is in parallel with 5 ohm. Is in parallel with 5 ohm. So whatever is the voltage that is appearing across 5 ohm will also appear across the branch of 4 and 6 ohm. The branch of 4 and 6 ohm. So if we get to know this, we can apply voltage division rule. So if you know the voltage across 5 ohm, then our problem may be solved. So your next target is to find out the voltage across 5 ohm. Your next target is to find out the voltage across 5 ohm. The voltage across 5 ohm can be found out by using this formula. The formula was as simple as the already discussed thing. So formula can be, look at this formula, the same formula can be rewritten for 5 ohm. So T 5 ohm has got the relationship V square of 5 ohm upon R, and R is 5 in this case, So what we know is, we know the value of P 5 ohm. It is 10 into 4.18 watt, and this is V5. So here in this case, what you can do is V5 is equal to under root of 5 into 10 into 4.18. Yes, we have got this. So if this is so, we have got what is the total voltage that is appearing across 4 and 6. So it is same as that is appearing across 5 ohm. So 5 into 10 into 4.18. Now what does voltage division formula tells us? Voltage division formula can be used to find out voltage across 4 ohm as was decided. We need it. Okay, we need it. Look at this formula. So V4 is resistance of the same branch. So resistance of the same branch means if you want to find out voltage across 4 ohm, then 4 ohm is the same branch. Upon addition of the two resistances in series. So two resistances in series are 4 and 6. Two resistances in series are 4 and 6. So it is 4 plus 6. Into total voltage. Into total voltage is this 5 into 10 into 4.18. Yes, so V4 is found out. Now, I will rub few things that are unnecessary now, and will make some space for myself. So V4 is found out. Now, we shall start calculating the power. So V4 ohm was supposed to be calculated. Look at this formula. Instead of this, I will be substituting the value of V4 that is just found out. And it is 4 upon 10. It is 4 upon 10 into under root of 5 into 10 is 50 into 4.18, and square of this divided by the resistance value, that is 4. So now it becomes 16 by 100 into this 1 by 4 can be kept here, and this is square root will be removed, and this is what we get. So 150 can cancel in this manner, so it is 2 and 16 can cancel in this manner, it is 8. 4 and 8 can cancel in this manner, it is 2. So what you get is 2 into 4.18 watt, but they have asked you in calories per second, so it can be divided by 4.18, so it is 2 calories per second. This is your answer. Though I took a long time to solve this because I was supposed to make you understand also. But if you do it on your own by understanding this concept, this will not take this much of time, because the ultimately you must have understood that these steps were very easy. These steps were very easy. Okay, so finally you have got the answer, 2 calories per second. 2 calories per second. Now we shall, so here you have gone through a numerical based on power resistance relationship actually. The only thing was there was a twist in the unit that we usually use. Now, next numerical. The current I flowing in the circuit shown below in amperes rounded off to 1 decimal place is. So we have to find out current I. Where is current I? Look at this. Here is some current I that is to be found out, and this is the given circuit. So whatever information is to be given is given in the circuit itself. Nothing written in the words. Okay. Now firstly, you must identify what type of circuit is this, and then you can think of what ways can I do this. What type of circuit is, by the word what type of circuit I mean to say, what does it consist of? It simply consists of resistors. It consists of one DC voltage source, and look at this, this is a current source. Yes, this is a current source. So circuit consists of one current source over here, one current source over here. Okay, ideal current source. Okay, ideal current source. And look at this, circuit consists of one dependent source, because it is a diamond. As I said, diamond shape of sources represent dependent sources, and inside it, if there are polarities positive and negative mentioned, then it is voltage source. So in that case it is dependent voltage source, dependent voltage source. And instead of this, had there been a diagram of such a kind wherein arrow is mentioned, then it would have been dependent current source. Now, what does this voltage source depend upon? Look at this. It depends upon current, some current. So this voltage source can be called as current dependent voltage source. This is how you have to be very sure about what type of source is present. Current dependent voltage source. Some of you may unnecessarily get confused over here by looking at the I. Some of you may unnecessarily think that this is a current source. No, it is not a current source. Source is identified based on what is present inside the diamond. If inside the diamond there are plus and minus polarities, it is definitely dependent voltage source. It is definitely dependent voltage source. Dependent voltage source. And if inside the diamond there is present arrow, it is definitely dependent current source. The only thing is on what they depend upon is told by what is written beside them as magnitude. So here in this case it is written that it is 5I. It means that this voltage source depend upon some current in some other part of the same circuit. What is that other part of the circuit? Look at this. This is the I. So value of this dependent voltage source depends upon this value of current. So this is current dependent voltage source. And where is that current on which it is depending? Over here in the first branch, we can say, or the current that is coming out of the 20 volt source. Its magnitude depend the magnitude of this dependent voltage source depends upon current that is coming out of the battery. Current that is coming out of the battery. Okay. So first, once you identify what are the things present, you will be in a position to solve this numerical carefully and accurately. Now, what can be done in such a case? So, solving a circuit for some current has got many methods. By which you can do. But first choice, whenever it comes to finding current, whenever it comes to finding current, I would recommend your first choice should be applying Kirchhoff voltage law or mesh analysis. In other words, it is also called as mesh analysis. In other words, it is also called as mesh analysis. This is a thumb rule, okay? You can remember this. Whenever you want to find out some current, you can have your first choice of method as better you try to find it by Kirchhoff voltage law or mesh analysis. This may solve the numerical in very least amount of time. Okay, so let us try to prefer this. If at all we are not in a position to solve it by this, we will try to go ahead with some other mechanism, other method. Because method is not mentioned in the gate examination. Look at this. If you read this statement, you will not see any method mentioned over here. You just have to find out the I, whichever method you find suitable. Okay, now the choice is with us. So we will try to apply Kirchhoff voltage law or mesh analysis method to this circuit. I am redrawing it because I have already done many things in the available circuit. So to make it clearly visible to you again, I would do this, redrawing it. So this was the simplest form of circuit available, and 2 ohm. Here was some current I that is to be found out. This is to be found out, and this is 20 volt. So let us start applying Kirchhoff voltage law. Now, when you apply Kirchhoff voltage law, the first thing that you must understand is, it completely depends upon your understanding about writing the algebraic summation of voltages. Why? Because Kirchhoff voltage law states that algebraic summation of all the voltages in a closed loop is equal to 0. So we have the expression as algebraic summation of voltages is equal to 0. And while doing so, what is to be taken care of is rise in potential should be considered positive and fall in potential should be considered negative. Now look at this. What should be considered rise in potential? What should be considered fall in potential? The other way also is okay. All right. So rise in potential can be considered negative, but if we do that, then fall in potential has to be considered positive. Okay. But what we will stick to is we will consider rise in potential as positive, fall in potential as negative. Now, here are two things to be taken care of. Firstly, you have to trace the circuit from some point. Let us call this point A, B, C, D, E, F, A. So we will move across the circuit from A, we'll go to B, we'll go to C, we will go to D, we will go to E. Sorry, not exactly like this. This will be taken care of later on. What we need to do is, when you are tracing the circuit, you have to start from some point A and you have to travel across the circuit. It is like tracing or traveling across the circuit. It is like tracing or traveling across the circuit from one point, and you have to come back to that point. Assuming that the circuit branches are your path. Okay. So while doing so, let us take an example of some other circuit. Okay. While doing so, I am trying to make you understand firstly the concept of rise in potential and fall in potential. Let us assume I is the current that is flowing in such a circuit. So how do we write we will start from this point, some A, We will go to point B, we will go to point C, we will go to point D, and then we will come back to point A. So A, B, C, D, A is our path of tracing, is our path of tracing the circuit, is our path of tracing the circuit. So we are moving from A to B, A to B. So while moving from A to B, what you come across? You come across a battery of 10 volt. And when you come across a battery of 10 volt, you are supposed to write 10 volt only. You are supposed to write 10, not plus or minus. Plus or minus, we will discuss it later on. When you move from B to C, you come across 2 ohm resistance. So potential drop across 2 ohm resistance will be 2 into current through that resistance, that is 2I. When you move from C to D, you come across 4 ohm resistance, and potential drop across 4 ohm will be 4 ohm into I. And we have to write it is equal to 0. Now only thing remained is whether we should write plus 10 or minus 10, whether we should write plus 2I or minus 2I, whether we should write plus 4I or minus 4I. This has to be concluded. Okay, the conclusion is based on the rising potential or falling potential concept. Now look at this. When you are moving from A to B, you were actually moving from negative plate of the battery to positive plate of the battery. So negative plate की तरफ से positive plate की तरफ जाना is as good as moving from lower side to higher side. Moving from lower side to higher side. So such a thing is rise in potential. We understand that. Such a thing is rise in potential. We understand that. So 10 will be written as plus 10. Now when you are moving from B to C, you are writing voltage drop across 2 ohm, and you don't know what is happening, whether rise in potential is taking place or fall in potential is taking place. Why? Because as battery was self-sufficient to inform you about this, resistors are not self-sufficient to inform you about this. Okay, battery is self-sufficient to tell you whether you are moving from lower side to higher side or from higher side of potential to lower side of potential. But as far as resistors are concerned, resistors don't have any such information whether you are moving from higher side of potential to lower side or from lower side of potential to higher side. So what do we do then? Then we have to take help of some other thing or other parameter. We can take help of current. We can take help of current because current we know always flows from higher potential to lower potential. Current always flows from higher potential to lower potential. So in case of 2 ohm, current is flowing from this end of 2 ohm to this end. It means this must be the higher side and this must be the lower side of potential. That is why current is flowing in this manner. That is why current is flowing in this manner. Now look at this. Now you were traveling from B to C. So you were traveling from plus to minus. So you came across fall in potential. So you came across fall in potential. That is why you are writing minus over here. Now look at the I. I is flowing in 4 ohm in this direction. So in the downward direction. So if it is so, it can only happen when 4 ohms upper terminal is on higher side and 4 ohms lower terminal is on the lower side. So if this is happening and you were traveling from C to D, it means you came across fall in potential. So fall in potential has to be written negative. So this is how we get the Kirchhoff voltage law equations or mesh equations when we apply KVL. So thumb rule over here is battery is self-sufficient to inform you about its battery is self-sufficient to inform you about its rise in potential or fall in potential thing. But resistors are not capable of doing so. Resistors are not capable of doing so. So you have to take help of current. So what can be made a thumb rule is if you and current. In case of resistors, when you want to decide whether it is rise in potential or fall in potential, there are thumb rules. U and current if are moving in the same direction, U and current in same direction, then potential drop should be considered negative. When U and current, U means you were traveling, right? You were traveling, that is why U. U and current in opposite direction, then potential drop should be considered positive. Then potential drop should be considered positive. So you can make a note of this and we will apply these thumb rules and we will write the equations. Okay. So I shall rub these unnecessary things now. We'll have some clean space. Okay. Now we shall try to apply Kirchhoff voltage law to the two loops available over here. Okay. Now, if you try to, here in this case again there is a twist. Here in this case again there is a twist. If you try to write a KVL equation for loop number 1, let us assume, then you will come across some, let us start doing it. We will travel from A to B. You will travel from A to B and you will come across 20 volt, and that too it is rise in potential because you are moving from lower side of potential to higher side of potential. Then if you travel across 2 ohm branch, you will write it 2 into I. So it is, you look at this, you are moving in this direction, I is also moving in this direction. So U and current are moving in the same direction. As I said, when U and current are moving in the same direction, potential difference should be written negative. Now when you are moving from C to F, when you are moving from C to F, we do not know the voltage across current source of 2 ampere. This is a current source, right? Ideal current source. Unless and until given, you never know the voltage across current source. The voltage across current source. That is why you will not be able to write this equation. You do not know what is to be written over here, and then you will be writing 0, but you don't know this value, voltage across the current source. So this equation is completely, but it means we cannot write such an equation. So what in such a case be done? So let me tell you, here is one such concluding point again. Whenever you have a vertical branch, by the word vertical I mean to say a branch common in two loops, having current source, then the two loops actually are called as one single loop or one single mesh, and that mesh is called as super mesh. Because you cannot write voltage value for that vertical branch, you will not be able to write KVL equation for any of the two loops. आप किसी भी एक loop के लिए equation नहीं लिख पाओगे. That is why what do is we consider the outer loop to write the equation. What is outer loop in this case? It is A to B to then C to then D, then E, F and A. Okay, so we will move across the boundary of this circuit to write the Kirchhoff voltage law equation or KVL equation. Okay, done. So while moving from A to B, I come across 20 volt. While moving from B to C, I come across 2 into I, and current are moving in the same direction. So that is why minus 2I. We don't need to go down, we need to go to C to D. So when I go to C to D, I come across 3 ohm. What is the current through 3 ohm? It can be clearly seen that current through 3 ohm will be this 2 plus this I. So 2 plus I will be current through 3 ohm, and this will flow downward also. So 3 into 2 plus I is the voltage drop across 3 ohm, and because 2 plus I, the current, and U are moving in the same direction, both are moving from C to D, it should be written minus. And now you come across a voltage source, dependent voltage source. Dependent voltage source is telling you that you are moving from plus to minus, so you are coming across fall in potential. That is why this is also minus 5I. And you came to E to F there is nothing, F to A there is nothing, so is equal to 0. So when you try to simply solve this equation, you will, I hope it can be done now. So 2 into 3, 2 plus 3, 5, 5 plus 10, so 10I, and minus 6 is what will remain, is equal to 0. What we get is 10I is equal to 14 and I is equal to 1.4 ampere. So though I took it a long time to explain it to you, you on your own will be able to solve it very in very less time once you understand the concept. Okay, I hope this is also understood. So here in this case, I am trying to explain you the concept as well as the solution of the numerical. That is why it is taking some time. Now we shall go to another numerical. Again, look at the numerical. It consists of voltage source, ideal voltage source, ideal current source, and then dependent current source. So this is where you should take care of. So it is not difficult to solve, but you have to be very careful while looking at the sources and concluding few things. In the given circuit, the parameter K is positive and the power dissipated in 2 ohm resistor is 12.5 watt. Look at this. Power is given over here, and as I said, it has got the unit watt. So 12.5 watt is given. So this is kind of a numerical based on power resistance relationship along with Kirchhoff laws, because their meshes can be seen. The value of K is, so we have to find out the value of K over here, and they have mentioned that K is positive, So what can be done is, firstly focus on what is given and what can be found out. So if power across 2 ohm is given, where is 2 ohm? Look at this. Here is that 2 ohm. And we have some V0 unknown, the voltage appearing across 2 ohm, and on that value of V0, the value of current source depends. So value of current source depends. But we know P2 ohm can be in this case given as voltage across 2 ohm, and voltage across 2 ohm is V0, square of that divided by 2 ohm. So this is now a known formula to all of you. It is V square by R. So V0 is voltage across 2 ohms. So that is why V0 square is equal to, or this implies. What does this implies is, we have got 12.5 is equal to V0 square upon 2. So this implies V0 square is equal to 25. So this implies V0 is 5. Yes. So something is achieved from given 5 volt. Okay, 5 volt. So V0, which was not known, has been found out. Now, how do we use this V0? How do we use this V0? Now you can also think of for a minute, and I will also think of what can be done. So I will let you know the solution. If you come along with some solution, please let me know. We can make it interactive for you. Okay, so I think this can be the simplest way of solving it. Yes. So look at this. This current source, I hope you understand the significance of current source. Current source. current source's responsibility is to maintain fixed current in the branch where it is present. So as 5 ampere is present over here, its responsibility is to maintain 5 ampere in this branch. Whatever other changes happen in the circuit, it doesn't care of. If here is 5 ampere, it means here is 5 ampere. So at this point, if you look at, this is 5 ampere, and the current, again this is a current source, so this will maintain a current of kV0 in this branch. So as we can see, 5 ampere will actually be addition of the two currents. 5 ampere will actually be addition of two currents. Current from 2 ohm, or current that is coming from 2 ohm, and current that is coming from the vertical branch, that is K into V0. So K into V0, I2 ohm plus K into V0 is equal to 5 ohm. And I2 ohm can be found out by knowing V2 ohm upon 2. So what is V2 ohm? We know that V2 ohm is already V0. So V0 upon 2 plus K into V0 is equal to 5. And V0 is already found out. V0 is 5. So this is 5 by 2 plus K into 5 is equal to 5. So this is 2.5. So 5K is equal to 5 minus 2.5. So 2.5, and K is equal to 2.5 upon 5. So it is 0.5. Yes. So answer for K is 0.5. So it was very simple numerical. The only thing was we had to understand the distribution of current, and we have to understand this very clearly. The significance of current source, or the important property of current source. Current source maintain the constant current in the branch where it is present. Okay, I hope this is understood. You can take screenshots of the things on the screen once the solution is over, so that you can have the solutions later on. Okay, we shall go ahead. In fact, I will be sharing the link of the video on YouTube, so you can revisit the video, no problem. Now let us talk about this circuit. In the circuit shown below, the voltage and current sources are ideal. The voltage across the current source in volts is. So they have asked us to find out this voltage. Look at this carefully. They have asked us to find out this voltage, and this is the voltage across current source. Yes, this is the voltage across current source, and they have asked us to find out this voltage. Yes. So in such a case, some of you may unnecessarily fear about finding it out, or some of you may find it that this is very simple numerical. But yes, it is simple, but for those who understand the significance of presence of current source and what will now happen in this circuit. So as I said, so this circuit is actually as good as only this much of circuit. Five ampere, 2 ohm, 10 volt. There is nothing present ahead of this, so we need not draw these branches. They are as good as dummy branches, right? So unnecessarily it may be confusing to someone. So this is the V out voltage that is to be found out. This is the V out voltage that is to be found out. Now, in such a circuit, if there is nothing over here, then 5 ampere will flow through. Yes, the job of current source is to maintain the constant current in the branch where it is present. So while maintaining 5 ampere over here, it is possible only when all the 5 ampere flows in the 2 ohm when all the 5 ampere flows into 2 ohm. So 2 ohm will carry the current of 5 ampere. This is for sure true. And this 5 ampere again will come down, and this 5 ampere will again be over here. So ultimately what it means is, because of the presence of current source over here, the constant current that is flowing in the circuit is of 5 ampere. So when 5 ampere is flowing in 2 ohm, potential difference will be 10 volt. 5 into 2 is 10 volt. And current is moving in this direction. Current is moving in this direction. So it means this must be the higher side of potential and this must be the lower side of potential. So current flows from higher side to lower side. So if it is so, then 10 volt must be having this as the higher side and this as the lower side. So ultimately what it reduces to, if we try to look at it in this manner, then assume as if here is a source of this polarity, and somebody has asked you what will be the voltage between these 2 points A and B. So let us assume these were the points A and B. These were the points A and B. So while doing such a thing, what we do is we prefer here is some battery of unknown voltage. Okay, VAB. We have to find out VAB or V out. VO was the name. So what we will do is we will move across the circuit in this manner and apply KVL. Okay, so from B to A, when I move, I get V, rise in potential. From A to C and then D. A to C, when I move, I have moved from B to A. Okay, then I have to move from A to C. So you come across fall in potential. Why? Because you are moving from positive plate of the battery to negative plate. So fall in potential. Then you move from again fall in potential, C to D. So minus 10 is equal to 0. So ultimately it gives us V is equal to 20 volt. VO is equal to 10 volt. So answer is VO is equal to 20 volt. So this was very simple. The only thing is you must take care of the presence of current source. You must understand that 5 ampere will be flowing in this circuit. You must understand that voltage across 2 ohm will be 10 volt. You must understand the polarities of 10 volt will be like this. And then it is easy to find out that VO is equal to 20 volt. Okay, I hope this is also understood. We are moving ahead. Now, in the given circuit, the current supplied by the battery in ampere is. So again, we have to find out some current. Current supplied by the battery. Okay, look at the current supplied by the battery. Current supplied by the battery is I1. So ultimately, we have to find out the value of I1. Is what does it mean? Yes, so I1 is to be found out. And if we find out I1, then our job is done. Now look at the circuit carefully. What does it consist of? It consists of one voltage source, ideal DC voltage source, and other is current source, the diamond, dependent current source, the dependent current source. And now, because as I said, whatever is written beside the dependent source actually tells us its magnitude. So it is written I2. It means current in this branch will be maintained I2. Current in this branch will be maintained I2 by this dependent source, and in 1 ohm also, if you look at this, it is written that I2 is flowing. So it ultimately concludes to us that here in this case I1 is simply equal to I2 in the downward direction and again I2 in the 1 ohm direction. So this means I1 is equal to twice I2 or I2 is equal to 0.5 I1 or half I1. Yes, so this is what we have so far. So we have one equation with us. This may be useful. Yes, this will be useful. Now what can be done is, yes, looking at the circuit, we can simply conclude that we can apply KVL, Kirchhoff Voltage Law. As I said, that can be the simplest thing that you can do. We will apply the KVL. So let us start moving from point A. We will move to point B. We will reach to point C, and when you are moving in the downward direction, you will note that there is a presence of current source. The voltage across current source is never known. So as I said, this is again a case of super mesh. This is again a case of super mesh. So you cannot move down. So you will move to D, you will move to E, and you will move to F. And then again back to A. So whenever there is a vertical branch of current source present between the two loops, we cannot write two different equations for each loop having the common branch of current source, and hence we have to write the equation for outer loop or outer mesh, and that mesh is called as super mesh. That mesh is called as super mesh. Okay, so I would write that equation from A to B. When I go, I come across 1 volt, and that too I come across a rise in potential. So then I and current I1 are moving in the same direction. So 1 into I1 is negative for us because I am moving from B to C, and I1 is also moving from B to C. Then I am moving from C to D. I2 is also moving from C to D. So 1 into I2, that is negative. I am moving from D to E. I2 is also moving from D to E. I2 is also moving from D to E. So minus 1 into I2. When I am moving from E to F, nothing is there. F to A, nothing is there. So this is done. This is equal to 0. So what I get is 1 is equal to 1 into I1. So I1, 2 into I2 plus 2I2. This is the second equation. Now instead of I2, half of I1 can be substituted from equation 1. So this gives me I1 plus I1 is equal to 1. So this implies I1 is equal to 0.5 ampere. Yes, so this is the answer for I1, 0.5 ampere. Okay, so I hope this is also understood. One more thing that should be concluded over here is, what happens is, whenever there is a super mesh, whenever there is a vertical common branch between the two loops, we, instead of getting two KVL equations, one for each loop, we get only one equation for super mesh. One equation for super mesh, and this is how we usually have I1 and I2, two currents for two meshes, and we have only one equation. So as far as mathematical linear algebra is concerned, you have got less number of equations than the number of variables to be evaluated. So in such a case, the other equation is always given by the common branch. The other equation is always given by the common branch. So here in this case also, this is what we could get because of the common branch. So the equation which was otherwise could have been got had this not been super mesh can be achieved by looking carefully at the common branch. Okay. In the circuit shown below, the node voltage VA is okay. Now you have to look at this carefully. First kind of a numerical we can say. So far we haven't been asked the voltages. So look at the circuit. What is present in the circuit? A voltage source is present over here. Yes. A current source is present over here. Yes. And this is, look at the polarities. Polarities, instead of being mentioned inside the diamond, they are mentioned outside the diamond, beside the diamond. So this is again a dependent voltage source, but it depends on current. Which current? I1. I1 is over here. And now we have to find out voltage VA. So VA is voltage at this point. VA is voltage at this point. So what can be done in such cases? What can be done in such cases? So whenever you want to find the voltage, your first choice should be KCL or nodal analysis. Please remember this. Okay, this is a thumb rule that will save your time during examination. And whenever you want to evaluate current, you can think of KVL or mesh analysis, because when we write the equations for mesh analysis or we write the Kirchhoff voltage law equation, actually currents are involved. If you remember, we wrote the equations such as 20 1i plus some 2i2. So look at this, though this is a KVL equation, but currents are parameters. So ultimately currents can be found out by using KVL. Similarly, when we write KCL, Kirchhoff current law equation or nodal analysis equation, voltages are involved as parameters and voltages can be evaluated. So please keep this in mind. Okay, please keep, this is the thumb rule. Okay, the other way also possible, but it takes time then. If you want to find current, then nodal analysis can also be used, but it takes more time. When you want to find current, when you want to find voltages, mesh analysis can be also used, but then it takes more time. So this can be considered as thumb rule to save your time. Okay, save your time. Now let us start as I said, let us apply the thumb rule. The thumb rule is we will go ahead with the nodal analysis. So at node A, we will write KCL equation. At node A, we will write KCL equation. And KCL equations, while writing, we will assume outgoing currents are negative and incoming currents are positive. Okay, incoming currents are positive. Such as, look at this 5 ampere can be seen that it is an incoming current for VA. It is an incoming current for VA. Okay, better I redraw this circuit because it seems some people may not understand it. Okay, so this is minus plus 10 I1 and this is 4 ohm. This is 5 ohm and this is 10 volt of source. Now look at this. Instead of drawing the 5 ampere source in this manner as is drawn, I would draw it in this fashion so that you understand that this is node A. This is node A. So here in this case, this is node A and this is also node A. So instead of drawing it 3 points, I am drawing it only 1 point, and then you will better be understanding. Yes, very good. Now we have 3 branches meeting at node A. Sorry, 4. We have 4 branches. 4 branches at node A. It means we have to write algebraic sum of 4 currents equal to 0. Yes. The only thing is now we have to think of the 4 currents carefully. So one current is very well already be given. The one current that is given is 5 ampere. 5 ampere is incoming current over here. So 5 ampere is incoming current over here. But we are not provided with any value of current that is moving in 5 ohm, any value of current that is moving in this 5 ohm and any value of current that is moving in this 5 and 5 or 10 ohm. So what we need to do is we have to assume them. We will assume as if the currents that are not given are all outgoing currents. Okay, what we are assuming is currents that are not given or that are not mentioned. Currents that are not mentioned are all outgoing. You can assume incoming also. Okay, not a problem. Currents that are moving are all outgoing. So let us call this current some I1. यहाँ पे तो 5 एम्पियर पता है. Let us call this current some I2. Let us call this current some I3. Outgoing is moving away from the node. Okay, here it is given I1. Okay, here it is given I1. See, look at this. Here it is given I1. So if you change it on your own, it will unnecessarily carry, and that is why it cannot be called I1. So I will call it I3. So at node A, when I start applying, then I start applying the Kirchhoff current law or nodal analysis. I should write the equation as, look at this carefully. I3 is moving away, so minus. 5 ampere is coming in or incoming current, so plus. I2 is moving away, so minus, and I1 is also moving away from the node, so minus is equal to 0. So this is the simplest step that you should firstly do. This is the simplest step that you should firstly do instead of making it complicated and then unnecessarily making it difficult for you. So now minus, instead of I3 we shall write the I3 in terms of voltage. What is I3? I3 is current through 5 ohm. So current through 5 ohm, if somebody asks you what can be it, I3 is current through 5 ohm, so you should write it as V5 ohm, voltage across 5 ohm upon 5 ohm. Yes, voltage across 5 ohm in this case is, let us assume this is ground. Ground is not given, so you have to assume a ground. So what is voltage across 5 ohm? Voltage across 5 ohm is VA minus voltage of ground 0 divided by 5. Look at this. This is a 5 ohm branch. This is a 5 ohm branch connected between VA and ground. What is voltage across this? Voltage across this is VA minus 0. And what will be current? VA minus 0 upon 5. Yes, so this is as simple as that. Okay, so I hope this is now understood and we can repeat these things for the other branches. So I3 is simply VA upon 5 plus 5 as it was minus, what will be I2? I2 is, look at this carefully, I2 is a current through 5 ohm, a current through 5 ohm in the circuit, and the 5 ohm is of this manner. 5 ohm is over here. Here it is VA and here it is 10 I1. Okay, plus VA we can say. What is voltage difference across this? It is VA minus of minus 10 I1. And current will be divided by 5. So that is why we can write VA plus 10 I1 divided by 5. And then minus I1 is equal to simply VA minus 10, VA minus 10, VA over here and 10 over here divided by 5 plus 5, 10 is equal to 0. So we have written the branch currents, and now in terms of voltages. So in doing so, if you look at the equation carefully, there are only two unknowns in the equation. One is VA, which is to be found out, and other is I1, So VA is one unknown, and other is I1. So if we replace I1 intelligently, then this equation will be one equation and one variable, so it can be found out. So I1 can be so please think of how to replace I1. I1 is, yes, I1 is mentioned as current moving from 5 ohm, moving from A towards 5 ohm. So I1 is simply in this case VA minus 10 upon 10. So instead of this I1, we have to substitute the value VA minus 10 upon 10. And I hope after substitution you will be able to solve such equation, because it is only unnecessarily it will take some time to simplify these equations, because we can move ahead with some other numericals in that time. So if you substitute I1, there remains only one equation and one variable, so it can be solved, and what you get is VA is equal to, I know already the answer because I have solved these equations, so I keep it a homework for you. VA can be calculated to be 11.42. Okay, so here what was supposed to be understood was, why should you choose nodal analysis? Because voltage was asked. And voltage that was asked was some node voltage. So in such a case, your choice should be nodal analysis or KCL. And while doing so, you should take care of writing such KCL equation. That's it. Okay. Now we shall go to some other question. You might be also knowing that some numericals based on graphical theory or graph theory also appear in the examination. So in such a case, you have to be known about some formulae used for calculating the number of nodal equations and number of mesh equations possible. I will let you know that during this numerical. Graph associated with an electrical network. I hope you remember the graph. Yes, you remember the graphs that are plotted in this manner. Let us assume you might have heard of some graphs of this kind, tree and graphs. Okay, so these were the graphs, and these are called the nodes. So a question is dependent on your knowledge about graph theory. The graph associated with an electrical network has 7 branches. So number of branches are given. Number of branches represented as small b, 7. And then number of 5 nodes. Number of nodes is 5. Let us call it n, and it is 5. Then what is asked is number of independent KCL equations and number of independent KVL equations respectively. Okay, so listen to me carefully. There are simply direct formulae to find this out. You can note this formulae. Number of KCL equations. And one more thing, you should also understand that it is a number of nodal equations, because we just in the previous numerical gone through the nodal analysis, where we understand that nodal analysis is actually writing KCL equations for one node, for each node. So as many number of nodes. For example, if here are 4 nodes, so number of nodes and number of KCL equations have equal relationship with them. That relationship will be explored over here. Okay. So number of KCL equations and one of these nodes is ground node. Okay. One of these node is ground node. So that is why it is not 4. It is 1 less than the number of nodes. It is 1 less than the number of nodes. But number of KCL equations and number of nodal equations are same, and those can be found out by the formula n minus 1, where n is this, sorry, small n, number of nodes, small n. So here in this case it is 5 minus 1, this is equal to 4. This is equal to 4. Now, number of KVL equations is asked. Number of KVL equations is asked. So number of KVL equations is, the formula is B minus n minus 1. Okay, B minus n minus 1. So where B is number of branches 7 minus n is 5 minus 1. So it becomes 3. It becomes 3. So number of KVL equations is also called as number of mesh equations. Number of mesh equations. So sometimes they ask number of KVL equations, or sometimes they ask number of mesh equations. So you have to be very careful about both the words. You have to be careful about both the words. They mean one and the same thing. They mean one and the same thing. Okay. So shall we move ahead? Yes, we can go ahead. Just let me see the participants. Yes, okay, you are present. I thought I was speaking since a long time. Yes, somebody wants to speak something. Is it okay? Is it all right that we are going with? There are still some 2 to 3 numericals that we have to wind up before the time. We can go ahead till 11:25, not a problem, but still it may take some time. So better I go on. Now, the power supplied by the 25-volt source in the figure shown below is, now what is asked is power supplied by the 25-volt source. Source is over here. Source is over here. And we have to find out the power supplied by this source. And now please pay an attention. Any circuit, if you talk about wherein a source is given, a voltage source, and number of such resistances and other things are connected, anything can be connected. Okay, we don't matter what is connected in the circuit if we want to find out the power. Why? Because power supplied by the source can be found out by knowing its voltage value V and knowing what is the amount of current that is coming out of that source. If you know these two things, you don't need to know, or you don't need to bother what are connected across it. But sometimes to find out this current, we have to bother about what are the things connected. Then only we find out then we only are in position to find out this current. So now, as you could understand, to find out power supplied by the 25 volt is as good as multiplying 25 volt with current that is coming out of this 25 volt. If you look at this, current that is coming out of this is mentioned as I. Yes, current that is coming out of 25 volt is already mentioned as I. So your job is to find out the value of I. Your job is to find out the value of I, and your problem is solved. Okay, I hope we can move ahead. Now, as I said, to find out the value of current, first thing that should come to your mind is mesh analysis. or KVL. Okay, or KVL. So we can go ahead, to write down the equation for mesh analysis. See, let me tell you, we will not be able to solve it using mesh analysis, but still I am telling you, as I told you, your first choice will be applying KVL or mesh analysis, so we shall do that. Okay, so 25 minus I into R1 minus 14 ampere is written over here. Oh, okay. So 14 ampere is the current moving downwards through R2. So 14 R2 will be drop across it is equal to 0. So we have got one equation. And this gives me 25 minus, instead of R1, what is given is, instead of the I into R1, 17 volt is already written. So 17 can be written over here. Look at this. Voltage drop across R1 is given at 17 volts. So instead of I into R1, we can write 17 minus 14 into R2. So what can be evaluated is R2 can be evaluated. Now, once we know the value of R2, we can go ahead in finding out the value of R1 and then. But this is taking unnecessarily too much of time is what I wanted to tell you. Why? If you look at the circuit carefully, though we were applying KVL and we may get the answer, this is a lengthy process as far as the given numerical is concerned. How? Look at this. It is shown that I is moving here and down to this R2 line 14 ampere of current is moving, and here is another current which is coming to be 0.4 I. So if you write KCL equation at this node, you will have only one variable. In both the cases it is I. So you will evaluate it in one step only. So let us apply KCL at this step. So incoming current, I is incoming, right? So it is written positive. 14 ampere is outgoing. Look at 14 ampere is moving downward, right? So it is outgoing current. So minus 14. And again, incoming current of 0.4 into I, sorry, it is I, not I1, and is equal to 0. So here in this case, there was only one unknown, I. So had you taken care of, so I plus 0.4 I is equal to I is equal to, sorry, is equal to 14, is equal to 14. So I is equal to 10 ampere. So job was very simple. Had you looked at the circuit carefully, it was a one-step task to find out I, and if we do not get to know that this is the simplest way and we focus on our regular method of mesh analysis and KVL, then also it is possible. But you see, firstly you will evaluate R2, then now you may evaluate R1, which was not needed. Once you know R1 and R2, then you may have found out the current I. So it was unnecessarily going lengthy. So once you know I is equal to 10, power P is equal to 25 into 10. So this much is 250 watt. So sometimes, though thumb rules are given, you have to carefully look at the circuit if there any shortcut is possible by looking at the given information. And gate examination is all about this. It is not always that you need to employ the complete method. Okay. Now we shall go to, yes, the favorite of all of you, Thevenin's theorem. Okay, so we have got some 3 numericals of Thevenin's theorem to be conducted before we end the session today. So please be patient. For the network given in figure below, the Thevenin's voltage VEB is. Now, we know that Thevenin's theorem is one of the important theorems employed for solving the numericals. So VTH, Thevenin's voltage, is always the open circuit voltage across some terminals of load branch, and those terminals are usually A and B. So here again, A and B are shown over here, across which we are supposed to find out the voltage, and they already have named it as Thevenin's voltage. Okay, so we will redraw this circuit. And we will think of what can be the shortest way and what are the steps that are causing trouble to us. What are the branches that are causing trouble to our understanding? And we will replace those branches by suitable replacements. So 16 volt is what is given, 10 ohm, 5, 10 and 6 ampere. And instead of showing A over here, this A can be shown in this manner also. This B can be shown in this manner. Okay, so we have to find out the voltage between A and B. And this is also point A, this is also point B. So we have to find out voltage difference between the point A and point B. Now, your first perception or your understanding of voltages should be very clear. So look at this circuit. Looking at the circuit, we usually consider the return path as ground. So here in this case, B point can be considered as ground. So ultimately, you have to find out voltage VA with respect to ground, and that's your job. So here in this case, VA is as good as finding out VTH. Now, this is, let us assume A, then you have two ways of doing it. Look at this. What are the ways that are connecting A to ground? We firstly should explore or should look at that. So these are the ways from left hand side which are connecting A to B or ground. 10 ohm, 5. Now, if somebody tells you what is the voltage across V10, and if somebody tells you what is the voltage across 5 ohm, then your job is done. Or if somebody tells you what is the voltage across 6 ampere, then also your job is done. But nobody is telling you what is the voltage across 6 ampere, and nobody is telling you what is the voltage across 5 ohm or what is the voltage across 10 ohm. That is why you are in a position of not knowing the voltage of A with respect to ground, and hence the Thevenin's voltage. There was other way also. Okay, you could have looked at the right hand side. So either way, this is possible. To be done. You can do it in both the ways. Ultimately, had you been aware of the voltages, this would have been possible. But if you are not aware of the voltages, then you have to think of circuit carefully. Now, this is not required. This was just for making you understand. Now, as I said, whenever you want to find out voltage, so look at this, it is as good as finding voltage VA at node A. Your choice should be, now, because we are finding voltage, we can use nodal analysis. And for finding current, we use mesh analysis. So if we apply if we apply just a minute, I am just making it clearly visible again. So if we apply nodal analysis at node A, we will be able to find out voltage A with respect to ground, that is here in this case voltage VAB. So instead of making it unnecessarily complicated, let me make it VA only. Okay. We know that VA in this case is VAB because B is at ground, So let us write down the KCL equation. For this. But in fact, before doing that, what can be done is, I would suggest you to convert this current source and this resistance into voltage source. I would suggest you to convert. This will reduce one step. Okay. So converting a current source into voltage source is possible. We know 6 into 5, 30. So voltage source will be of the magnitude 30 volt. The only thing is you have to take care of polarity as the current is moving down. So polarities will be plus on the lower side. And 5 ohm comes into series. So 5 ohms should come over here. So instead of these two branches, we have got a new branch appearing over here. And ahead of it, everything should remain as it was. So this was 10 ohm. This is where you have got VA and this is what it was. Okay, so 10 ohm and 16 volt. Now it is easy for us to write down the nodal equation. And we should do it and we will get the answer very soon. So I have made it simplified for you firstly. Now, how many branches are there meeting at node A? So look at this. This branch can be drawn in this manner. Okay, this branch can be drawn in this manner. So this is simply to be understood. This is the third branch. Okay, so there are three currents. Okay, which are the currents? Whatever are the currents that are not known, the directions of which are not known, we will assume them as if they are moving away. So let us assume one current is moving away in this direction, one is moving downward and the other is moving away in this direction. So the current that is moving away towards 30 volt can be given as VA, okay, minus of minus 30 divided by 15 ohm. And this is moving away, that is why this is minus. Then current that is moving downwards is VA minus ground, that is 0 upon 10. And as this is moving away, so this is also minus. Then VA minus 16 upon 10. So again this is moving away, so minus is equal to 0. Now all minuses can be made plus as if they are moved to the other side of the equation. So this gives me VA plus 30 upon 15 plus VA upon 10 plus VA upon 10 minus 16 upon 10. And now if you look at the LCM will be 30. So 30 if we is multiplied to this equation, we get is 2 into VA plus 60 plus 3 into VA plus 3 into VA and minus 48. So this is equal to 0. So you can solve this definitely, because here is only one variable and one equation. So we can get the answer for this. One equation, one variable is very easy. So VA is equal to, if you solve it, it will be 1.5 volt, minus 1.5 volt. So as I said, this was very simple. The only thing is people unnecessarily fear about the Thevenin theorem. So if you start looking at the circuits carefully, if you understand their orientation carefully, these are very simple circuits. Okay, I hope this was understood. Okay, moving ahead. For the given circuit, the Thevenin voltage, Thevenin equivalent is to be determined. The Thevenin voltage VTH seen from terminal AB. Okay, so again we are supposed to find out the voltage between points V, AB, and when we look at the circuit from this side. So this is called VTH. This is called VTH. VAB and VTH are same, and we have to look at the circuit from open terminals A and B. Now again, it is finding VAB is actually as good as finding voltage across 2 ohm. Look at the circuit carefully. Finding VAB is like actually we are supposed to find out the voltage across 2 ohm. And voltage across 2 ohm can be found out if you know current through 2 ohm and already you know value of 2 ohm. So I into R. So current through 2 ohm is known to us, then that current into the resistance 2 ohm will give us the value of voltage across 2 ohm. Yes. So your next target can be finding the value of current through 2 ohm. Current through 2 ohm in this direction. Current through 2 ohm is what we actually need to do. If that is done, then we are done with finding out voltage between points A and B. So these are points A and B. Look at this carefully. Okay. So shall we start doing it? Yes. So let us assume let us call this current something very simple so that we don't write complicated equations. We know that this current is to be found out. Let us call this current some I1. Let us call this current some I1. Okay, we will call this current some I1, and in that case what we will get is, now if this is assumed I1, so this I1 must have come from this branch. This I1 must have come from this branch. Okay, because there is nothing division kind of thing is happening. Circuit beyond point A is open. Beyond point A, there is no circuit other than the branch 2 ohm. So whatever current must have come as I1 must have come from this branch. So ultimately, this means current over here or over here is I plus I1, is I plus I1. So don't make unnecessary complications in any circuit. Whatever values are given, you have to use those. Here in this case, I was given. Okay, so you cannot overwrite I by any other thing, or unnecessary recalculations have to be done later on. So here in this case, current that will come out of 2 volt source will be I plus I1. Now let us write, as I said, our target is to evaluate current. So to evaluate current, what we use is, we use mesh analysis. We prefer mesh analysis or loop analysis. So let us write loop equation for loop number 1. So let us move from this side to the upper side. So when I come across 2 volt, while moving from the bottom side to upper side, I am moving from negative plate of the battery to positive plate, so it is plus 2 volt. And now I come across 1 ohm resistance, and inside 1 ohm the current that is flowing is I plus I1, and current I plus I1 is moving in the right side direction, and I am also moving in the right side direction while tracing it, so I would write it minus. Now moving downwards, there is, I come across 1 ohm, and 1 ohm has got the current I flowing through it. Current I is moving downwards. I am also moving downward while traveling or tracing across the circuit. Then that is why this should be minus. So this is equal to 0. So this gives me I so is equal to 2I plus I1. Okay, 2I plus I1 is what we get at the end of this equation. So let us call this equation number 1. Let us call this equation number 1. Now we shall write Kirchhoff voltage law equation for loop number 2. So while doing so, let us move from this point. Let us move from this point downward, and then so let us call this C to D. We will move from C to D, then to B, then to A, and then again back to C. You can choose any direction that you want, okay, but you have to come back to the point from where you started. Okay, while moving from C to D, I come across 1 ohm, and current through 1 ohm is I, and I and current small I are moving in the same direction from C to D. That is why this is minus. Okay, between D to B there is nothing. So while moving from B to A, look at this, I come across the resistance of 2 ohm, and 2 ohm is carrying the current of carrying the current of I1. So potential drop will be 2I1. But now here in this case, I am moving from B to A, and current is moving from A to B. So I and current are moving in opposite direction. That is why this is plus. That is why this is plus. Okay, I am repeating it. While moving or tracing the circuit from B to A, I was moving from B to A, but current I1 was moving from A to B. So that is why I and current are in opposite direction. So the potential drop should be considered positive. Now while moving from A to C, I come across a dependent voltage source. I come across dependent voltage source, which magnitude is 20I. And now I am moving from positive terminal of the dependent voltage source to negative terminal. So it is as good as fall in potential. That is why it should be written minus. It should be written minus. And I have reached to C, the starting point. So this is equal to 0. Now what I get is I can get 21I is equal to 2I1. Okay, and I can be 2 by 21 I1. This is my equation number 2. Now let us substitute this value of equation number 2 in equation number 1. So what I get is 2 is equal to 2 into, instead of I would write 2 by 21 I1, 21 I1 plus I1. So this becomes 4 by 21 I1 plus I1. This becomes 25 I1 by 21 2. So what I get is I1 is equal to 21 by 25 into 2. So this is 42 by 25, and this comes out to be, it comes out to 1.68 ampere. So as decided, we have found the current through 2 ohm. We have found the current through 2 ohm, that is I1. So current through 2 ohm was I1. So 1.68 into 2. So VTH or VAB is equal to 3.36 volt. This is how you find out the value for voltage between terminals A and B by using Thevenin's understanding or Thevenin's theorem understanding. Okay, here actually no such thing has been used as Thevenin theorem, but the voltage that is found out is actually the concept of Thevenin's voltage. Okay, we shall move ahead. And this is the last numerical of today's session. So don't leave the meeting unless we finish it, and I will share with you some Google form wherein you have to mark your attendance. Otherwise, your attendance will not be calculated. And moreover, your feedback will be very essential for us, for me personally, to improve upon. Okay, so I hope you will be giving a feedback for the session. Now, in the circuit shown below, the maximum power transferred to the resistor R is. Now look at this. This is the numerical based on maximum power transfer theorem. Maximum power transfer theorem. What does maximum power transfer theorem tells us? Maximum power transfer theorem tells us that in any DC circuit, maximum power can be transferred to load resistance RL only if RL is equal to, only if that load resistance is equal to internal resistance of the network. And internal resistance of the network, in other words, is also mean by Thevenin resistance of the network. Also mean Thevenin resistance of the network. And power maximum that can be delivered in such case is found out by derivation to be equal to VTH square by 4RL, and ultimately it means VTH square by 4 into RTH. So what we need to do is we have to find out the value of maximum power transferred to the resistor. So we have to find out P max. So what we need to use this formula. And if we need to use this formula, we need to find VTH and RTH. Yes, correct. So though it seems to be the numerical of maximum power transfer theorem, without employing Thevenin's theorem, this is not possible for us. So it is kind of numerical based on maximum power transfer theorem as well as Thevenin's theorem. Okay. So we shall go ahead to find out the voltage VTH. Okay, so voltage VTH, and voltage VTH can be found out. They are asking us the maximum power across resistor R, right? So across resistor R, so this branch be opened. To find the voltage VTH, we know the load branch, the branch of interest should be opened. The branch of interest should be opened. So we will redraw the circuit and we will remove it. Very interesting numerical this is. There are some twists again. Moving ahead. Five ohm. It's 3 ohm, 6 volt, and it's 5 ohm. Now here you can see was present a branch which needs to be removed, and when it is removed, the open terminals should be called A and B. So for the sake of understanding, I can call them A over here. For the sake of understanding, I can call it B over here. Okay, so what you need to find out is VTH. Ultimately, you need to find out VAB. And as I said, again, here is a ground path. So this is ground. So ultimately, you can simply find out VA and your job is done. And your job is done. So to find out voltage, what we need to do? We need to employ nodal analysis. We need to employ nodal analysis. Yes, very true. So at the nodes, we must understand what are the currents that are coming, or what are the currents that are moving away. What are the currents that are moving away? Or is there any other way out? Or there is any other way out? Yes. Is there anyone wanted to talk something? No. So there is other way out, I guess. Okay, as I told you in the previous numerical, but we did not use that mechanism that way. Here is a shortest way possible. Here is the shortest way possible. What can be the shortest way? As I said, you should firstly trace the path between A and ground. And if you know what are the voltages across that path, you don't need to do anything else. Now, to find out VA, the only obstacle is you don't know the voltage across 5 ohm. Otherwise, you know the 5 volt. Look at this. From A to ground, there are only two voltages that are going to appear. V 5 ohm and simply 5 volt. And simply 5 volt. So if you somehow find out voltage across 5 ohm, your VA is found out. So your next target is to find out V5 ohm. Okay, so finding out V5 ohm is possible if you already know that resistance is 5 ohm, then you should only know the current, and your job is done. So our next target is to find out current through 5 ohm. Which 5 ohm? This 5 ohm. Okay. So that is why we changed our target. We changed our target to finding out the current through 5 ohm. Now we shall move ahead. And let us call this current B I. So if I look at the loop carefully, there is only one loop till this 5 ohm branch, or not A, let us call this X, Y, Z, okay, Q. So from X, Y, Z, Q point of view, you get one loop X, Y, Z, Q, X. This is one loop to which I can apply KVL, and let us call the current that is flowing through this loop as I. So let us move from Q to X, then from X to Y, then from Y to Z, and Z to Q, and then Q to X again. So from Q to X, when I move, I get 5 volt. Then from X to Y, I have two things to be written. That is 5 into I, and current and I are moving in the same direction. So minus, and then plus 6 volt, because it is rise in potential for the battery. You don't need to look at the parallel branch because we are looking at the loop. That is outer loop for the sake of understanding. And then minus 5 into I, and that's it, is equal to 0. So look at this. Here there is only one unknown. Here there is only one unknown which can be evaluated. Okay, which can be evaluated. Is anything left in our case? No, I guess. Yes, 5 plus 6, 11. Yes, so 11 is equal to 10I. So this gives me I is equal to, I think something is remaining. Sorry. We cannot do it this way. Because here in this case, this should have got converted. Current source was left aside. I was thinking of this as dependent current source. Okay, so this should be converted firstly into the voltage source. Between the YZ, this should be converted into, look at this, these two should be converted into the voltage source. Otherwise, what will happen is we have to write the equation for this loop and while writing the equation for second loop, you will come across the current source and you won't have voltage across that current source. So it is as good as a super mesh, but you are seeing the branch from the outer side. Okay, so this will not solve our problem. Okay, that is why this cannot be done. You have to write equations for both loops in that case. And while writing the equation for second loop, you will come across the current source, and voltage across the current source is not known. Okay, this is not 2 ampere. This is now a voltage source converted. So 2, 5, 10. 2 into 5 are 10. So 10 volt of voltage source. So our equation modifies to, minus 5 into I and plus 10 is equal to 0. So this gives me minus 10I is equal to 11 plus 10 is equal to 21 minus 21. So I is equal to simply 21 by 10 is equal to 2.1. And as I said, voltage across 5 ohm is to be found out. Now voltage across 5 ohm will be V5 ohm will be I, that is 2.1 into 5 plus this 5 volt voltage, and your problem is solved. So this gives me VAB. This is A, this is B, 5 volt. This gives me in this case current is moving in this direction, so this is higher potential, this is lower potential. So let us write down the KVL. So VAB, instead of VAB we shall start from here. So 5 minus 2.1 into 5 plus VAB is equal to 0. So VAB, minus VAB is equal to 0. So VAB is equal to 5 minus 2.1 to 5. This gives me minus 5.5 volt. So VAB, that was supposed to be found out firstly, is found out, and VAB is VTH. Okay, so it is 5.5 minus 5.5. Now, so we shall note the value of minus 5.5 and we shall look at the finding out RTH. RTH unless found out, we cannot use the formula VTH square by 4 RL. Okay, so VTH is found out to be 5.5. So after all, we will be squaring 5.5 square. Okay, and before doing that, we need to find out value of RTH firstly. We can say this is minus 5.5. Now look at this circuit. Okay, between A and B, you have to find out the resistance. And while doing so, according to Thevenin's theorem, all the voltage sources should be replaced by short circuit. So instead of 5 volt, I am showing a short circuit connecting it. Now, moving ahead, here in this case, here was a 6 volt, so short circuited. Then here was a 5 ohm, and again a voltage source short circuited. That's it. So you might be wondering why I am not showing 3 ohm over here. Why? Because here is a short circuit because of the replacement of 6 volt voltage source. So when I am short circuiting these 2 points, such a resistance doesn't come into picture. Okay, I hope this is known already to all of us. Just wanted to make you remind. So between A and B, so let us assume current had been passing through A, then would have got divided in 2 parts. This current would reach to B, this current would reach to B. It means 5 and 5 are in parallel between A and B. So between A and B, replacement will be 5 parallel 5, 5 parallel 5, and as I said, r parallel r is always r by 2, so 5 parallel 5 will always will be 2.5. So in this case you have to substitute 2.5 instead of rth. So finally the value of p max will be equal to minus 5.5 square divided by 4 into 2.5, and if you calculate using calculator you will get 3.025 watt. So this is how it was to be solved. So as I said, as I am explaining it to you step by step, it is taking some time, but when you do it on your own, once you know the concept, it will not take this much of time, and you will be solving it in less than the time I am taking here. Okay, so just wait for a moment. I would post the link for feedback and attendance, and I would request you all to fill it immediately before you forget it. If you think the session was good, please mention accordingly. I'm stopping the presentation, but please be connected.